All right, step into the shoes of a master electrical inspector with me for a minute. Today, we're going to tear down a real, honestly pretty challenging question that you are incredibly likely to face on the 309A electrician exam. Passing this exam, it isn't just about knowing how to wire a receptacle out in the field. It's about knowing how to navigate the Canadian electrical code with absolute pinpoint precision. So let's dive right into this and see exactly how the examiners test your fundamental understanding of the code. Here is the exact setup you might see. Listen to this closely and chew on these four options. What is the maximum number of 400-watt MH indoor HID high bay luminaires that can be connected to a 120-volt commercial lighting circuit if each of their ballasts draw 2.4 amps? And your choices are 9, 12, 13, or 16. Now, what's really fascinating here is the way this is written. The exam writers, they've deliberately set a trap for you right in the text. They throw a ton of information your way. Some of it is absolutely crucial, but some of it is literally just there to lead you off a cliff if you aren't paying close attention. We are going to break the code down on this right now, piece by piece. So if you're serious about getting your license and mastering these kinds of tricky questions, definitely hit that like button and subscribe for more of these daily breakdowns. Let's uncover the answer together and make sure you dodge these common pitfalls on exam day. Okay, to solve this correctly, we have to separate the signal from the noise. We need to isolate our crucial keywords from the distraction numbers. Notice the distinct difference we're dealing with. On one hand, we have commercial lighting, HID and 120V. On the other hand, we have 400-watt and a 2.4 amp ballast draw. Here's the kicker. That 400-watt lamp rating, it is completely irrelevant here. Why? Because the code strictly requires us to size based on the actual current draw of the ballast, which is that 2.4 amps. But even more importantly, those words, commercial lighting, HID, and 120V, those are your golden keys. They dictate exactly which Canadian electrical code rule we have to apply to find our maximum breaker size. And those golden keys point us straight to Rule 3104 of the code, which handles protection. Let's walk through the logic. Step 1. We're in a commercial setting, right? The code calls this other than dwelling units, which drops us right into subrule B. Step 2. We are dealing with a high-intensity discharge, or HID load. Step 3, our input voltage does not exceed 120 volts nominal. When you follow those three specific conditions down to Rule 30-104B, 3IIB, the code explicitly spells out that the maximum overcurrent protection permitted for this specific branch circuit is 40 amps. And right there, that is exactly where the trap snaps shut. Picture this. You're sitting in the exam room, you're stressed for time, you feel the pressure. You take that 40 amp maximum protection, you divide it by the 2.4 amp draw of each ballast, and your calculator spits out 16.6. You look up at the multiple choice options, you see 16, and you confidently select it. But that 16 staring back at you? No way. It is undeniably incorrect. It's the classic bait and switch they want you to fall for, because doing that completely ignores one of the most critical safety concepts in the entire codebook. The missing puzzle piece is Rule 8-104. We absolutely cannot ignore the fundamental rule of maximum circuit loading. You see, commercial lighting is considered a continuous load. And why does that actually matter in the real world? Well, the code knows that when breakers are exposed to continuous loads for long periods, you get a significant, sometimes dangerous buildup of heat within that panel board enclosure. To stop that heat buildup from causing a premature failure, or worse, a fire hazard, Rule 8-104 steps in. It dictates that continuous loads simply must not exceed 80% of the overcurrent device's rating. Bottom line, you cannot load this commercial breaker to its full 100% capacity. So let's run the real numbers and apply this rule correctly. Step 1, we take our absolute maximum breaker size of 40 amps and we multiply it by 0.8 to apply our 80% continuous load D rating. That instantly gives us a maximum allowable continuous load limit of exactly 32 amps. Now for step 2. We take that safe D-rated limit of 32 amps and divide it by the 2.4 amp draw of a single ballast. And that gives us 13.33. Before we lock in our final answer, real talk for a second. Identifying the correct breaker size using Section 30, that is only half the battle. Applying the continuous load D rating from Section 8 is what actually earns you your license. Never, ever ignore the 80% continuous load rule on commercial lighting questions. Forgetting this one single step is quite literally the #1 reason apprentices fail this math in the exam room. Bringing it all back home to our original question, but this time with a clear head. Our math gave us exactly 13.33 luminaires. Since we're dealing with physical, real-world equipment, we obviously can't install a third of a light fixture, right? We have to safely round down to the nearest whole unit to make sure we do not exceed that hard 32 amp limit. So we round down to 13, making option C the undeniable, code-compliant, and 100% correct answer.
Look, don't leave your electrical license to chance. As we just saw, the tiny details and the cross-referencing between different code sections makes all the difference between passing and failing. For full 309A prep courses, much deeper code breakdowns, and hundreds of practice examples just like this one, head straight over to averdash.com. But I want to leave you with this to think about. How many other beautifully disguised trap answers are hiding in that codebook, just waiting for you on exam day? Get your prep done right the first time. Get that certificate in your hands, and I'll see you out in the field.
For more sample question, follow us.